Hello, welcome. We are solving simple problems as part of geometric progression and then specific topic sum to n terms. We have a problem. Let's try to solve it together. The sum of first three terms of a geometric progression is 16 and the sum of next three terms is 128. Find A, R and Sn. What is given to us? The sum of first three terms of a GP is 16 and the sum of next three terms is 128. Find A, R and Sn. We can do this in two ways. I will show you both the ways. First let us do it in using the Sn formula. Okay, now let the terms be first three terms and again we have three more terms, right? So I'll write them as A1, A2, A3, A4, A5 and A6. These are the six terms I have. Sum of first three terms of GP is 16. Now what is sum of first three terms? Is nothing but equal to S3. Will you agree with me? So we have been given that S3 is equal to 16. That is fine. What else we have been given? We have been given that sum of next three terms is 128. That means these three terms add up to 128. Now how I can write this in terms of Sn? If you see, let us write it down. This is first term, second term, third term, fourth term, fifth term, sixth term. Now you want sum of 4, 5 and 6. How to write it in the form of S of n. So what I will do is, I will say find out sum of 1 to 6. From that subtract sum of 1 to 3. So can I say nothing but S6 minus S3? Will you agree with me on that? What I am saying, sum of next three terms is nothing but sum of A4, A5, A6. That is nothing but equal to sum of all the six terms minus sum of the first three terms. Now we know the formula for this. So let us try to put them in the formula. Okay, right. Now what is S3? 16. So can I go ahead and say S6 minus 16 equal to 128. That gives me S6 equal to 144. And also we know S3 equal to 16. Now let's put the formula. What will be our formula? The first term is A1, because we have taken first term as A1. S3 equal to A1 into R to the power of n. That's nothing but R cube minus 1 by R minus 1. This is nothing but equal to S3. Now let us see what is S6. S6 equal to A1 into R to the power of n. That is R6, R to the power of 6 minus 1 by R minus 1. Now let us say this is equation number 1 and this is equation number 2. Now what I want to do, I want to divide 2 by 1 so that I can find out what is the value of R. So I will say 2 by 1 gives me, now we know S3 is nothing but equal to how much? 16. This is equal to 16 and S6 is nothing but equal to 144. So can I say S6 by S3 is equal to 144 divided by 16. That is nothing but equal to, so A1 into R to the power of 6 minus 1 divided by R minus 1, that whole thing divided by A1 into R cube minus 1 whole thing divided by R minus 1. If you simplify this, you will just get R cube plus 1. Nothing else, because R minus 1 cancels, A1 cancels. This is in the form of A square minus B square, A square minus B square divided by A minus B. This is in the form of A square minus B square divided by A minus B. A is R cube. So your answer is A plus B. That's nothing but equal to R cube plus 1. So what you know now? R cube plus 1 is equal to 9. That gives you R cube equal to 8 or r equal to 2. Now once you know r equal to 2, it is very simple to find out what is the value of a. How to find out the value of a? Substitute in any one of the formula. Let us substitute in S3 equal to 16. So we will say 16 equal to a1 into, we know this is nothing but equal to third term, r cube minus 1 by r minus 1. That's nothing but equal to a1 into r is 2, just now we found it, that is 8 minus 1 by 2 minus 1. That's nothing but equal to 7a1. So that gives me a1 equal to 16 by 7. So now I know a1 equal to 16 by 7, r equal to 2. Can you go ahead and write down the formula for this? Sn? Sn will be a1 into r to the power of n minus 1 by r minus 1. Now let's do this in another way. We can do this in another way also. Let us look at that way how we can solve that. What I will do in this approach is I will just take general geometric progression. ar square, ar cube, ar to the power of 4, ar to the power of 5. These are the 6 terms. We know the first 3 terms add up to 16 and the next 3 terms add up to 128. Now we add them. What is that? Nothing but a into 1 plus r square equal to 16. Similarly, what I get here? ar cube plus ar to the power of 4 plus ar to the power of 5 equal to 128. Can I take ar cube common here? I will have 1 plus r square equal to 128 here. Now let us say this is my equation number 1 and this is my equation number 2. You can see that 1 plus r square is common in both of them. So if I go ahead and say 2 divided by 1 so that I can get the value of r, I will have ar cube into 1 plus r square divided by a into 1 plus r square is nothing but equal to 128 divided by 16. That's equal to 8. Now a cancels out. I am left out with r cube equal to 8. That gives me r equal to 2. Now once you know r equal to 2, it's the same formula. What I will do now, I'll substitute in 1 and I will say a into 1 plus 2 square equal to 16, or a into 7 equal to 16, or a equal to 16 by 7. So you can see you do it without using the sum to n terms formula also. If you take a general geometric progression also, you can solve it. Okay, we will solve some more examples as part of geometric progressions and sum to n terms. Thanks for visiting. Bye for now.